In this video, we're going to go over graphing lines by taking and generating ordered pairs from the equation, plotting those ordered pairs, and then connecting the dots. So let's throw an example up here. Alright, so here we go. Graph y equals 2x plus 5. Now the general idea there is we're going to generate solutions that make this equation true. And there's different ways to do it, but the most straightforward way that is often used is to create a t-table for organizing your information, and then you just pick any value you want for x. I like choosing easy numbers to work with, so 0 is usually one I choose, 1 and 2. It only takes 2 points to create a line, but I usually like to do 3, that way if they don't line up I know something went wrong. So these are what I'm going to let each of my x values be, and then I'm going to plug each one of them into the equation in turn to determine what their y partner is. So if I plug a 0 in for x, I'm going to have y equals 2 times 0 plus 5. Then I just do the arithmetic there on the left, and that tells me that y equals 5. So that gives me the ordered pair 0, 5, but in the table it's just a 0 in the x column and a 5 in the y column. And if I come over to the graph and plot that, I'm not going to go left or right any because x is 0, and I'll go up 5 on the y-axis, and I'll have that point right there. I'm going to do that again for x equal to 1. That gives me y equals 2 times 1 plus 5. And then doing the math out on that, I'm going to get that y equals 7. So I put that in my table, and then if I plot that point, that means I go right 1 and then up 7. And that'll put me right there. And then if I do it again for x equal to 2, I'm going to get that y equals 2 times 2 plus 5, or y equals 9. So that gives me the ordered pair 2, 9. It's actually not going to fit on my grid, so I'm just going to let it float up there because it's up above the grid 1. And then to graph the line, that's just plotting points that are on the line. So to graph that line, I would just fill in the line that connects all those dots. And since we are graphing lines, it should be perfectly straight. All lines in math are straight lines. If it's not straight, it's a curve. So that's our line. And one of the things I always like to emphasize when I'm just introducing graphing is this line does not have 3 points. This line has infinitely many points. I've just bolded in 3 of them. What a line is made of is infinitely many points that have all bled together and created a line. And then the other thing is every point on that line is going to, if I plug in the x and y value for those points, it'll come out as a true statement in the original equation. And that's why we call it graphing the equation, because the line is a picture of the solution set of the equation. Alright, let's look at another example that's set up a little differently and see how we can work with that. Alright, let's graph y equals 2/3 x minus 3. I'm going to start, I'll make my xy table. And I always like to use 0, so I'm going to start by plugging 0 in. So y equals 2/3 times 0 minus 3. Now 2/3 times 0 is just 0. That's why I like 0. It makes stuff disappear. So y equals -3. We can go ahead and plot that point. So this time we go down 3, and we get that point there. Now in my previous example, if I followed what I did there, I would plug in a 1 and a 2, but I don't want to plug those in because I'll just show it in green, but then I'm going to undo it. So when I plug that in, I get 2/3 times 1 minus 3, so I'm going to, and 2/3 times 1 is 2/3, and then I have to subtract 3 from that. So not only am I doing fraction arithmetic, I'm going to end up having to graph a fraction as well, which can be done, it's just not as fun. And when we're choosing our x values over here, we can choose whatever we want, which means we can be strategic and choose ones that kill off the fractions instead of making us have to deal with the fractions. for example, if I chose an x of 3, that's going to cause the fraction to cancel out, and then I won't have to do the arithmetic with the fraction, and I won't be plotting fractional coordinates. Alright, so if I choose an x value that cancels off the denominator, 3 would work with that. There's a lot of 3's going on in this equation, so I want to emphasize this is the 3 that I've plugged in for x. And also, sometimes it's helpful when you're thinking of that 3, since we're in fraction land, to think of it as 3 over 1. 3 over 1 reduces to 3, but as a fraction, we can think of it as 3 over 1. And then it's easier to see that these 3's cancel off, leaving me with just 2 over 1, or 2. So I get y equals 2 minus 3, or y equals negative 1. So that gives me the order pair 3, negative 1, so I can graph that, and I'm set. So that's the idea, is just to be strategic about what x values you choose so you can avoid the fraction work. The next x value that would reduce out the 3 is a 6. Basically, anything that is a multiple of the denominator we want to go away, we'll cancel it out. So I'm going to go ahead and do the 6, and that'll give us our 3 points that I like to have. So with that, we have that y equals 2/3 times 6 over 1 minus the 3. And so here, the 6 and 3 reduce down to a 2. And then that 2 multiplies with this 2, giving us 4. So we have y equals 4 minus 3, or y equals 1. So that gives us the order pair 6, 1, and we can plot that over here. And since they all line up, we hope that means we did something right. We can go ahead and connect the dots. Alright, so that's graphing 1 involving a fraction and how to choose your x values wisely to alleviate that fraction work. Let's do one more example. Alright, let's say we have 2x plus 3y equals to 9, and we need to graph that one. This one's different because it's not set up solved for y. And when they're like this, you can just go ahead and start plugging x and y values in this form. However, I like to go ahead and reconfigure the equation so it is solved for y, and that way I can better see how to avoid the fractions like we saw in our previous example. So to solve it for y, we basically want to get y by itself. So I'm going to start by subtracting 2x from both sides. That's going to give me 3y equals negative 2x plus 9. And if you want to write 9 minus 2x, that's perfectly okay. I've been programmed to put the x term first, but either order is algebraically equivalent. Then to get y by itself, I need to divide by a 3. Need to divide the right side by a 3. So on the left, the 3's cancel off, leaving me with the y, which is what I was wanting. I was wanting to get y by itself, equals. Now you got to be really careful on the right side here. This is a very common mistake, but the 3 has to be distributed to both of the terms in the numerator. So essentially I'm dividing the negative 2x by 3, and I'm also dividing the 9 by 3. Now actually doing that math gives me negative 2/3 x plus 3. And now it looks a lot like what we saw in our previous example. So the idea there is if you're given an equation where it's not solved for y, the strategy I would recommend is that you solve it for y to start with, and then that helps you know what order pairs to generate so that you can determine what order pairs to generate so you can avoid the fractions. I'm going to clear out the work here and just keep our result for the sake of space for working, for generating some order pairs. Alright, so I pulled the solve for y equation up, And I also drew in the t-table. Like I said, I always like to use 0, and then our denominator here is a 3, so we want multiples of 3. So we're going to plug in a 3, and we're going to plug in a 6 to determine our y coordinates. So plugging in the y, we get the negative 2/3 times the 0. So plugging in the 0 for y, we get this, which just gives us y of 3. Okay, now we'll plug in the 3. Alright, on this one, when I plugged it in, I went ahead and plugged in the 3/1. So to emphasize that my 3 was in the numerator, and then that cancels off my denominator in the 2/3, leaving me with negative 2 plus 3. So y equals 1. So now I have the order pair 3, 1. Okay, and then plugging in the 6, like we saw before, that's going to reduce down to a 2. So now it's really important. I'm going to take this 2 times a negative 2. Sometimes that negative gets lost, so be careful with that. That's going to give me a negative 4 plus 3, which equals a negative 1. Alright, with that, I can go ahead and plot those points out. 0, 3 is there. 3, 1 is here. And 6, negative 1 will be there. And they all line up, so I do a little celebration on the inside as I sketch in my line. And there we have it. Alright, so that's graphing a line by generating ordered pairs. We saw 3 different versions of that to kind of look at some different complexities you might encounter. Go ahead and give some of these a try and see how you fare.